The arrival of the third confirmed interstellar object, designated 3I Atlas, in the inner solar system represents a watershed moment in the history of astronomy and the search for extraterrestrial intelligence, SETI. This paper provides a comprehensive, multidisciplinary analysis of the object's trajectory, physical properties, and the cascade of anomalous characteristics that have confounded conventional astrophysical models. We examine the data from a holistic perspective, weighing the natural planetesimal hypothesis against the more speculative, yet statistically significant technosignature hypothesis. The global observational campaign, the philosophical and societal implications, and the future of interstellar object studies are discussed in detail. The evidence suggests that 3I Atlas is either the most extraordinary natural comet ever observed, forcing a revision of planetary formation models, or it constitutes the first credible evidence for extraterrestrial technology, with profound consequences for our species. Table of Contents. Prologue. A message from the cosmic dark. Section 1. Discovery and orbital dynamics. Section 2. A cascade of anomalies, the core data. Section 3. The Great Scientific Schism, natural versus artificial hypotheses. Section 4. The Global Observational Campaign, a coordinated scientific response. Section 5. Historical context and the Fermi paradox. Section 6. Philosophical, ethical, and societal implications. Section 7. Future horizons, the path forward for interstellar science. Epilogue. The awaiting truth. Prologue. A message from the cosmic dark. The silence of the cosmos is a misconception born of our own sensory and technological limitations. The interstellar medium is not a perfect void. It is a dynamic ocean, teeming with the gravitational wakes of dark matter, the magnetic ghosts of dead stars, and the countless frozen remnants of planetary systems that never were. For millennia, humanity's understanding of the universe was confined to our own solar backyard. The stars were immutable points of light, and the space between them an impassable, empty gulf. This paradigm began to shift with the dawn of the space age, but it was shattered on October 19, 2017, with the discovery of 1I Almutmore. This first interstellar interloper was a tantalizing but frustratingly brief glimpse beyond our heliosphere. Its anomalous acceleration and lack of a visible coma sparked the first mainstream scientific debates about the possibility of artificial origins. In 2019, 2I Borisov offered a more familiar visage, classic, active comet, albeit one with a unique chemical signature. These were the first two messengers, cryptic postcards from the galactic disk. But the third messenger, 3I Atlas, is different. It is not a postcard. It is a dense, complex manuscript, each page of which reveals a new chapter of mysteries. Its passage through our solar system is a leave-fire exercise in the scientific method, a real-time test of our models, our biases, and our capacity to confront the truth. It challenges us to distinguish between the extraordinarily natural and the marginally possible, forcing upon us a conversation that has, until now, resided largely in the realm of science fiction. Section 1. Discovery and Orbital Dynamics, the First Clues. 1.1. The Atlas System, Our Planetary Century. The discovery of 3I Atlas is a testament to the pragmatic, defensive infrastructure humanity has built to protect itself. The Asteroid Terrestrial Impact Last Alert System, ATLAS, operated by the University of Hawaii and funded by NASA, is a network of telescopes designed with a singular, grim purpose: to provide a final warning days or weeks of an impending asteroid impact on Earth. It is a system that scans the sky for existential threats. On the night of July 1st, 2025, one of its telescopes in Chile identified a faint 19th magnitude object. Its slow motion against the stellar background was unremarkable at first glance, but the automated orbit-fitting algorithms developed to calculate trajectories of near-Earth objects immediately flagged it as an extreme outlier. 1.2 hyperbolic velocity and interstellar provenance. Within hours of the initial report, astronomers at the Minor Planet Center, MPC, the global clearinghouse for such data, performed preliminary calculations. The results were electrifying. The object, provisionally designated a 25001, was moving at a heliocentric velocity of approximately 62.5 kilometers per second, 225,000 kilometers per hour. Crucially, its orbital eccentricity was calculated to be 1.3. An eccentricity of 1.0 represents a parabolic orbit, barely unbound from the Sun. Anything greater than 1.0 is hyperbolic, meaning the object possesses excess kinetic energy and is not gravitationally tied to our solar system. An eccentricity of 1.3 was unequivocal. This was an interstellar object, only the third ever confirmed. Its pre-encounter trajectory, traced back through the galaxy, suggested an origin in the general direction of the constellation Lyra within the galactic plane. It had likely been traveling for millions, if not billions, of years through the interstellar void before its chance encounter with our star. 1.3 orbital refinement and gravitational keyholes. As weeks turned into months and hundreds of additional astrometric measurements were collected from observatories worldwide, the orbit of 3I-ATLAS was refined to an astonishing degree of precision. This is when the first layer of true anomalies emerged. The object's path was not a simple, clean hyperbola. It was a path that demonstrated a series of intricate gravitational interactions. Ecliptic coplanarity. Despite its high inclination retrograde orbit, 3.1, Atlas was found to be moving within a remarkably tight 3.8 degree inclination to the ecliptic plane. The probability of a randomly incoming interstellar object achieving such a precise alignment with the plane of our planets is statistically minuscule, on the order of 0.15%. Planetary flyby sequence. Its trajectory was not a distant flyby. It was a carefully choreographed dance through the inner solar system. It passed within 0.4 astronomical units of Mars, used Venus's gravity for a slight trajectory modification, and its outbound path would take it close to Jupiter. The cumulative probability for this specific sequence of gravitational encounters, calculated through Monte Carlo simulations of random incoming bodies, was found to be less than 0.004%. The perihelion obscuration. The most temporally coincidental anomaly was its perihelion passage. On October 29, 2025, it reached its closest point to the Sun at a distance of approximately 0.36 astronomical units, 54 million kilometers. At this moment of peak heating and maximum potential activity, its position in the sky was almost exactly behind the Sun as viewed from Earth. This solar conjunction rendered it unobservable by all ground-based and most Earth-orbiting telescopes for a critical 3-week period. It was, as one commentator noted, as if it knew to hide in the one blind spot of Earth's entire astronomical infrastructure at the most important moment. Section 2. A cascade of anomalies, the core data. The object's peculiar path was only the beginning. As it plunged sunward, a global network of telescopes began to dissect its physical nature, revealing a series of characteristics that each, in isolation, was puzzling, and in combination were profoundly troubling. 2.1. The Luminosity Enigma. A blue star in a comet's garb. The photometric data for 3I Atlas was unlike any recorded for a natural comet. Pre-perihelion, red-green phase. Initially, it exhibited a reddish hue, consistent with a surface rich in complex organic tholins. As it approached within 1.5 astronomical units of the Sun, it developed a green tinge, a known signature of diatomic carbon Chelsea U, gas fluorescing in sunlight. Post-perihelion, the blue phase. When it re-emerged from solar conjunction in mid-November, the astronomical community was stunned. The comet's coma and nascent tail shone with an intense, saturated blue light. Spectrographic analysis confirmed this was not a trick of the light. The blue signature was the result of massive, sustained emission from carbon monoxide ions, CO. While CO is known to emit blue light, the sheer intensity and volume were unprecedented. The object's color temperature was measured to be higher than that of the Sun's photosphere, 5,800 K. For a passive body heated solely by stellar radiation, this is a thermodynamic impossibility. This blue star temperature glow, as it was termed, constituted a direct violation of standard thermal models. 2.2 Non-gravitational acceleration. The invisible engine. Precise Doppler radar and optical tracking from the Goldstone Solar System radar and the ESA Gaia spacecraft revealed that 3I ATLAS was not following a purely gravitational path. It was exhibiting significant non-gravitational acceleration. In comets, this is typically caused by outgassing the jetting of volatiles acting as natural thrusters. However, the profile of this acceleration was anomalous. Consistent thrust profile, the acceleration was remarkably smooth and constant. It lacked the stochastic kicks and variations characteristic of a tumbling, irregularly outgassing nucleus. The force profile resembled a low-thrust, continuous propulsion system, more than the chaotic venting of a dirty snowball. Magnitude. The delta V imparted by this acceleration was an order of magnitude greater relative to its size than that observed in even highly active solar system comets like Hale-Bopp. 2.3 Physical and compositional paradoxes. Further observations deepened the mystery. The metallic iceberg. Spectra from the James Webb Space Telescope, JWST, revealed a nucleus with an albedo of over 35%, far higher than the 3 to 5% typical for cometary nuclei. More startling was the composition. The reflectance spectrum indicated a surface rich in nickel-iron alloys, with ratios resembling certain stainless steels more than the primitive chondritic material of natural asteroids and comets. Its estimated water ice content was a mere 2 to 4%, making it drier than the Atacama Desert. The term metallic iceberg was coined to describe it. The wow signal resonance. In an almost poetic coincidence, astrophysicist Avi Loeb publicly noted that the radiant of 3 IATLAS's incoming trajectory was coincident with the sky location of the famous WOW signal, a strong, unexplained narrowband radio signal detected in 1977. While the probability of this being a true association is low, the symbolic resonance was powerful. Two of the most enduring SETI mysteries, separated by 48 years, pointing to the same patch of sky. Polarization anomaly. Light polarization measurements of the coma showed a pattern completely divorced from all known natural scattering models, whether from dust, water ice, or CO gas. It displayed a coherence and structure that one researcher described as ordered, not stochastic. Section 3. The Great Scientific Schism, Natural versus Artificial Hypothesis. The data forced the scientific community into two broadly defined and often contentious camps. 3.1. The Consensus View, the Planetesimal Hypothesis. The majority of astronomers, led by figures like Dr. Darrell Seligman, advocate for a natural explanation. They argue that 3 IATLAS is a planetesimal, a building block of a planet from a stellar system radically different from our own. Explaining the blue glow, they posit that the object has a massive subsurface reservoir of solid carbon monoxide. As it was heated, the CO sublimated not in gentle jets, but in a cataclysmic, near-uniform shell of gas release, creating the immense CO coma. The high temperature is an illusion caused by the specific fluorescence of this gas under extreme ultraviolet flux. Explaining the acceleration. The smooth acceleration is attributed to this symmetric, powerful outgassing from a very porous, low-density nucleus. A consistency of the thrust suggests a uniform internal structure and a lack of large, solid chunks. Explaining the composition, the high metal content and low water ice are simply a reflection of its formation in a hot, inner region of its protoplanetary disk, later ejected by gravitational interactions. We are seeing for the first time a Mercury core analog from another star. For this camp, 3IATLAS is a Rosetta Stone from a foreign planetary system, demonstrating the incredible diversity of outcomes in the planet formation process. The anomalies are not signs of intelligence, but signs of our own parochialism. 3.2. The Technosignature Hypothesis, the case for artificiality, championed by Professor Avi Loeb and a growing number of interdisciplinary scientists. This camp does not claim proof, but argues that the confluence of anomalies warrants the serious consideration of a non-natural origin. The cumulative improbability. Loeb's central argument is statistical. He has enumerated 10 distinct anomalous properties, assigning conservative, independent probabilities to each. For example, 0.2% for ecliptic alignment, 1% for sunward jets, 1% for the WOW alignment, etc. The combined probability of all occurring together in a single object is less than 1 in 1,015, 1 in 1 quadrillion. At this point, he argues, Occam's razor flips. The simplest explanation is no longer a natural object with 10 near impossible traits. but a single non-natural cause, an artificial object. The engine interpretation. The non-gravitational acceleration is interpreted as the signature of a dormant, malfunctioning, or purposefully low-power propulsion system. The smooth profile is exactly what one would expect from a machine. The hull interpretation. The nickel-iron spectrum and high albedo are consistent with the manufactured hull, designed for longevity in the interstellar medium. The low water content is expected for a technological artifact, not a primordial ice ball. The behavior interpretation. The trajectory using planetary gravity assists for a grand tour while hiding at the key moment is precisely the behavior of a reconnaissance probe designed to survey a planetary system while minimizing its own detectability. This hypothesis reframes 3I-ATLA not as a rock, but as a potential von Neumann probe or a derelict interstellar vessel, a piece of galactic archaeological evidence. Section 4. The Global Observational Campaign, a coordinated scientific response. The controversy catalyzed the most intensive observational campaign ever directed at a single celestial object. 4.1. The Space-Based Sentinel Network. During the crucial perihelion period, humanity's eyes were its fleet of solar observatories. SOHO, NASA ESA, its LASCO C2 and C3 coronagraphs provided a continuous movie of the comet's approach and departure, tracking its dramatic brightening. GOES-19 NOAA, its new compact coronagraph CCOR21, captured high-resolution, high-cadence images revealing the initial structuring of the ion tail. Solar Orbiter ESA, its off-ecliptic vantage point provided a unique stereo view, allowing for 3D modeling of the comet's expansion. 4.2. The Serendipitous Sampling Mission. In a fortuitous alignment, NASA's Europa Clipper spacecraft en route to Jupiter was on a trajectory that took it directly through the extended ion tail of 3I-ATLAS in early November 2025. While it could not image the nucleus, its suite of particle analyzers like the MassPEX mass spectrometer performed the first ever in situ sampling of material from an interstellar object. The data, which will take months to fully analyze, promises a definitive breakdown of the isotopic ratios and complex chemistry of the coma, potentially providing a fingerprint of its home system. 4.3. The December 19th conjunction, a global focus. The upcoming closest approach to Earth on December 19, 2025, at a safe distance of approximately 0.18 astronomical units, is being treated as a scientific Olympiad. A coordinated campaign is underway. James Webb Space Telescope, JWST, will use its NIRSpec and MIRI instruments to perform deep molecular spectroscopy, searching for complex organic molecules and precise mineralogical identification. Hubble Space Telescope will conduct high-resolution UV and optical imaging to study jet dynamics and nucleus rotation. The Very Large Telescope, VLT, and ALMA will probe the comet at sub-millimeter wavelengths, mapping the thermal emission and dust grain composition. The Allen Telescope Array, SETI Institute, has been allocated thousands of hours to conduct a comprehensive search for artificial radio transmissions across a wide frequency band. Planetary Radar, Goldstone, Green Bank, will attempt to ping the nucleus with powerful radar signals, which could reveal its internal structure through radar tomography. Section 5. Historical context and the Fermi paradox. The 3I Atlas event cannot be viewed in isolation. It is a direct confrontation with the Fermi paradox. If the universe is teeming with life, where is everybody? For decades, the paradox has been solved by a series of cop-outs. Life is rare, intelligence is rarer, technology is fleeting, or interstellar travel. 3.1 ATLAS challenges all these assumptions simultaneously. If it is artificial, it suggests that intelligence is not vanishingly rare. Technology can be durable enough for interstellar travel, or at least interstellar sailing. The galaxy may be littered with such artifacts, and we are only now developing the capability to see them. It reframes the great silence not as evidence of absence, but as evidence of our own ignorance. We haven't been listening or looking in the right way. We expected radio signals, but we may instead be surrounded by silent, drifting archaeology. Section 6. Philosophical, ethical, and societal implications. The potential ramifications extend far beyond astrophysics. Philosophical disruption. Confirmation of an artificial origin would be the most profound event in human history, rivaling the Copernican and Darwinian revolutions combined. It would definitively end humanity's biological and intellectual solitude. Our philosophies, religions, and sense of place in the cosmos would undergo a seismic shift. The ethical dilemma. If it is a functional probe, should we attempt communication or observe only under a potential prime directive of our own making? If it is a derelict, do we have a right to retrieve it? Who speaks for Earth? These questions would immediately move from academic exercises to urgent policy debates in the UN Security Council. Societal impact. The initial response would likely be a mixture of awe, fear, and exhilaration. It could unite humanity under a common cosmic identity, or it could exacerbate global tensions as nations vie for the technological secrets it might hold. Protocols for such a discovery, like the largely defunct First Contact protocols, are woefully underdeveloped. Section 7. Future Horizons, the path forward for interstellar science. Regardless of its ultimate nature, 3IATLAS has inaugurated a new field of science, interstellar object studies. The Vera C. Rubin Observatory, scheduled to come online in 2026. Its Legacy Survey of Space and Time, LSST, is predicted to discover dozens of such interstellar visitors per year. We will move from studying rare curiosities to conducting population statistics. The Interceptor mission, the ESA, and NASA are now fast-tracking the Comet Interceptor mission, designed to wait in a Lagrange point for a suitable target. 3.1 ATLAS has proven that we must be prepared with a dedicated spacecraft, ready to launch at a moment's notice for a close-range rendezvous. Advanced technosignature searches. Future surveys will include artifact hunting as a core scientific goal, scanning for objects with anomalous light curves, spectra, and orbits. Epilogue, the awaiting truth. As you read this, the photons from 3IATLAS are streaming into the mirrors and detectors of the world's great observatories. In clean rooms at NASA and ESA, engineers are preparing the Europa Clipper data downlink. In offices from Harvard to Cambridge to Beijing, scientists are modeling, arguing, and waiting. The truth about 3I-ATLAS is not a fixed point. It is a destination we are approaching one dataset at a time. It may be that the final analysis reveals a bizarre but natural cosmic phenomenon forever expanding our definition of comet. Or the data may lead us irrevocably to a conclusion that will echo through the remainder of human history. We are not alone. The universe has not merely sent us a riddle. It has provided a complex, multi-layered puzzle box. We have just begun to work on the lock. The next 45 days are not a wait. They are the most thrilling scientific investigation of our lifetimes. The cosmos is speaking. It is our profound privilege to finally be learning how to listen.